Okay, so for this question, it's a little bit different. The main difference with this question is that there's a 5n and there's a 3n, so there's sort of two numbers with power to them, and they're different from each other. The other thing is that it says is even, but that don't get confused by that. That just means is divisible by 2. So this is another divisibility induction question. Let's start off with our base case. So we have to show that this 5n plus 3n is even. So let's start off with our base case of, well, it's for all integers n greater than or equal to 1. So let's start with 1. So when n equals 1, we have 5 to the power of 1 plus 3 to the power of 1, which is equal to 8, and that is even. Okay, so therefore it's true for n equals 1, which is the base case. Okay, so now that we have a base case done, we can follow on with our assumption, our inductive step, I should say. So first of all, our assumption is that we're assuming it's true for n equals k. Okay, pretty standard, nothing out of the ordinary. And so what that would mean is that 5 to the k plus 3 to the k is even, so we represent that using 2j, so 2 times some integer. So we should specify where j is an integer. Okay, so let's follow on with our inductive step now. We are trying to prove that it's true for n equals k plus 1. Alright, so for the next integer. So well, what would that mean? Let's have our little required to prove step. Okay, so we're trying to prove that 5 to the k plus 1 plus 3 to the k plus 1 is now equal, so well, we should say is even. Okay, because we're gonna do this 2 times some letter for an integer step later on as well. We don't need to specify another integer here. Well, it's gonna be annoying to keep track of letters. Okay, so how should we go about this? Well, we know that we're going to have to use our assumption at some point. Let's see if we can use our assumption somewhere here. Well, in the form that it's in now, there's not really any easy substitutions that I can make that would simplify these things. So I'm just going to make one change to this first before I, and I should maybe zoom this out a bit so you can see. We should do one little step before we make any assumptions. Sorry, before we make any substitutions using our assumption, and that is that 5 to the k plus 1 is the same as 5 times 5 to the k. Okay, and that's the same for this. And I'll highlight what this means in a second and why this is the case. If you just remember the law, that, well, when you have, say anything, I'm just going to use 5, to the power of something, some power, well then that's equal to, it's sort of the reverse of this law, it's equal to this, right? When you have things of the same, when you have things of the same base, and they're multiplying each other, the powers, they just add each other. Okay, so I can just like how I add 2 and 1 to get to 3, I can just split it up. Okay, and that's what I'm doing here. Right, this is 5 to the 1 times the 5 to the k, okay, which is equal to 5 to the k plus 1. So I'm just sort of splitting it up using that index law. Let's get this out of the way now. So now that we have it in terms of something like this, I think it's a little bit easier to make another substitution out because, well, look at the 5k's and the 5k's and the 3k's and the 3k's up here. it's a little clearer to see the similarities. So we can say that this is equal. Let's make the substitution now. Now you can rearrange this if you want to leave a little bit of maybe a few lines or two, like one or two lines of space in between here, like at this point. If you want to leave that so that you can rearrange, this whole thing, you can do that. But I've just chosen to leave it like that because I can sort of, the rearranging of that, it's not too difficult for me. I can sort of just put it in straight away. So we have to pick, in this case it's a little bit different. We have to pick which one we're going to substitute into. It doesn't really matter which one, but we want to pick something to substitute into this so that everything's in terms of the same sort of term, right? So if we pick the 5k, if we want to keep it as 5k's, then that means that the 3k needs to be changed to 2j minus 5k so that we have just 5k's now. And if we pick the 3k to stay the same, then we need to change the 5k to be 2j minus 3k. Okay, so let's just pick the 5k to stay the same. That means that we want to sub this 5k by 2j minus 3k. So now we have it. Oh, sorry. We're trying to keep the 5k here. Well, again, it doesn't matter. I could have just kept going with that, but we're just trying to keep the 5k here. So then we have to change the 3k to be in terms of the 5k's. So it'll be 2j minus 5k. Okay. And now they're all in terms of 5k's. Okay, and so it's going to be a little bit easier to simplify these, to evaluate these things. So 5 times 5k. Let's expand this bit first. So 5 times 5 to the k, we'll just keep as that. But let's expand this bit so it'll be 6j, right? And minus 5k. I'm not going to, well, I can't really expand it into anything in this case. But you can also see now, well, the 5k and the 5 of the 5k's and the 3 of the 5k's, they're sort of like terms, right? So it's going to be 5 minus 3 to get 2 of the 5k's. Well, I should say 5 to the power of k. That's what I mean by 5k's. So now we're going to get 2 times 5 to the k here, and then we're going to still leave the 6j here. So here is another tricky step that we sort of need to do. We want to, ultimately, we're showing that this is even, so we want to show that it's equal to some integer multiplied by 2. So when we're doing these proofs, normally going to use the assumption step, and then after that we're going to try to see if we can take out a 2. And if we could factorize out a 2, that means that we can factorize the 2 out, and so it'll be 2 times something. And generally speaking, it's going to be an integer. Okay, if it's not, then you've done something wrong. Maybe you have to find a different way of rearranging it so that it's clearer. But if we factor out a 2 from here right now, you're just going to get left with 5k in here. And then we're going to get 3j inside here. And let's see, so we have 2 times something. Is that something an integer? Because if it is an integer, then that means this whole thing is divisible by 2. Well, let's think, 5 to the k. Well, k is an integer, so it's going to be 5 to the power of an integer. So that's going to give me another integer, right? Especially because k is it's greater than or equal to 1 only, right? So we're only going to get integers. If k is 1, it's going to be 5. If k is 2, it's going to be 25. It's going to keep going. Only integers. And then plus 3j, well, we know that j is an integer. Okay? So it's going to be 3 times some integer. Well, that's going to keep it as an integer. Okay? Because 3 is also an integer. And so you're going to get 5k, which is an integer, and 3j, which is an integer. So you add them together, it's also going to be an integer. So this whole thing in the brackets is an integer. So it's 2 times some integer. So what we're going to say is it's 2 times, and we don't want to use j again because we already used it. So we're just going to use some letter. You can use any letter really. I'm going to use q. And then we also specify where q is an integer. Okay? So, and 2q is even, right? That's what we're trying to show. 2 times some integer means that that number is divisible by 2. Okay? And so therefore 2q is even, and so therefore we've shown that this is that this statement up here is even, and so that proves our inductive step. Okay, so together with the base case, well, let's say it's true for n equals k plus 1 first. Therefore, it's true for all integers, right? With the base case up the top that we proved. For all integers n greater than or equal to 1. Okay? So therefore, we have proven the original statement by mathematical induction. Okay, and I'm just going to give you a little overview of the proof right here and the solution. Okay, so as you can see, this one was a little bit different. You may be a bit not really used to the 5k and the 3k together, right? The different bases, how are you going to deal with that? Well, you just need to make sure that you convert one to be in terms of the other. It doesn't matter which you pick. I chose it to be 5k. I could have easily subbed in 2j minus 3k here, so that everything's in terms of 3k's, and then I would still be able to take out a 2. You can try that for yourself if you like. Yeah, so that assumption step to rearrange it to make it in terms of the just one of these, that's sort of a tricky step. And then, trying to factor out the 2, that's pretty standard. Whatever it is you're trying to divide it by, to prove that it's divisible by, you just take it out and then you show that whatever left that it's multiplying it by is an integer as well. Okay, and you have to actually think about it to make sure if it's an integer or not. There are ways in which you can rearrange it so that it's not, you don't actually know for sure that maybe that what you have inside that's multiplying the 2 is actually an integer. So you do have to be careful and you have to think about it. In this case, this is the right way to express it to ensure that it's an integer.